Hi, my name is Tanaz Panahi, and I would like to present our graduation project today. Our team consists of Muhammed Keçici, Meetan Panahi, and Berkay Ghaznavi under the supervision of Professor Aydin Yeşildirek. You can see our content for the presentation, and again, you can see more content. Project definition. The Shared Autonomous Vehicle Project is a graduation project that can meet high-tech requirements such as mapping, object detection, classification, and vehicle control. Detection of the road lines, traffic signs, and classification of objects are main purposes of this project. Also, localization and mapping together with the current data will create autonomous and safe driving. Project motivation is to bring solutions to traffic congestion, minimize carbon emissions, and prevent human-related accidents. Project goals are lane tracking with perception system, simultaneous localization and mapping, path planning, requesting the vehicle via user interface, and instant location traffic tracking. You can see the technical specifications. For example, detecting 20 traffic signs is a specification. You can see our block diagram and also system schematic. In the user interface, Kiwi framework is used. One of the many advantages of the Kiwi is that the code written in Kiwi can be run on many different platforms such as Android, Windows, Linux, and iOS. But along with the Kiwi, for the application to work on the Android, we need to use other tools. In this page, you can see the codes written for the background of the Kiwi. These two codes give us give the application the functions. For example, it lets the application to retrieve the username and the password and save it, and also it lets the customer to use a map so that he or she can zoom in or zoom out or choose the location of the person or the vehicle. For the user interface design, KiwiMD is used. KiwiMD is an open source framework which lets the developer use many pre-built widgets. For example, MD label or MD text. Here you can see the login page and the personal information page which the user can enter in the application. For map integration, many tools are used. Kiwi Garden is one of the main ones, which is which is a framework that will let the developer use map view and map marker, so the user can locate or mark a specific location or search a specific location on the application. Also, geocoding API is used to an external service that can convert a human readable address to a place into a geographic coordinates. For example, you can see in this page Istanbul coordinates. You can see the result of the map integration. In the search bar, you can search Davut Pasha and the map will show you the location. For Kiwi to be able to be run on Android, we need to use Bulldozer, which is available on Linux. And so for us to be able to use Linux, we need to use Ubuntu. In the Ubuntu, after running the commands, we will get the buildozer.spec file, which contains the application permissions and details, and also Python, which optimizes the performance of the Kiwi applications. And also min and max API are both important for the user because these two can let the user know which Android version the application supports. You can see the buildozer.specs files in the Ubuntu and building application after running the buildozer Android debug deploy run.
Simulations are performed in Roscadube environment. The G-mapping method used for SLAM. SLAM simulation results are shown in this page. For lane tracking in simulation, a code is written. Lane tracking simulation results are shown in this page.
Our mechanical design consists of two layers of plexiglass fixed on a chassis and electronic components on the plexiglass. The layers are attached to the chassis with plastic clamps. Our design features are mass 5 kg, length 430 mm, width 320 mm, and height is 300 mm. In addition, an electronic card was designed. The purpose of designing this electronic board is to have electronic components together and to reduce wiring. The motor driver is not included in this card due to problems that may arise in its heating. In this image, you can see the equipment on the card. Equipments are soldered on Pertinax at necessary points. We mounted the necessary components on the vehicle. We put the battery at the bottom in order to not to disturb the balance of the vehicle. Then we assembled the plexiglass parts. We attached the cables to the plexiglass parts. We tested them to find out our DC motor and servo motor capabilities. In this test, we checked the speed, torque and angular rotation characteristics of DC motor and servo motor.
Connection between ROS and Adafruit BNO055 IMU are made. You can see the Arduino and Python code of communication between IMU and ROS. Adafruit Ultimate GPS Breakout V3 tested via serial monitor. GPS and serial monitor are shown in this page. RP LiDAR A3M1 is used in the project. RP LiDAR A3M1 and its outputs are in this page. The mapping, which was carried out within the scope of the implementation of the project, was carried out using actor SLAM mapping over ROS. The results of the mapping study are shared on the next page. YOLO V7 and PyTorch framework were used for object detection. In order to realize the use of OpenCV and GPU, the artificial intelligence model was trained on Google Colab using various datasets. YOLO V7 ROS package used. The average accuracy is between 85 and 90%. For lane tracking, we are taking bird's-eye view of origin image, converting it to grayscale, using Gaussian blur filter in it, and making any edge direction in it. This is our final prototype.
You can see our project budget in this table. Some of the components we have were obtained from our consultant. Some parts were used from the budget provided by the TÜBİTAK Support Fund. Industry consultancy of our project is provided by LeoDrive. It's also funded by the TÜBİTAK 2209B program. You can see our working schedule on this page. The outputs we obtained at the end of this study are as follows: gain knowledge about autonomous vehicle technologies and share it with the industry. Presented of a project report that fulfills stakeholders' expectations, has specified technical specifications and functionality verified by simulations. Applied to the TÜBİTAK 2209B Industry-Oriented Research Project Support Program for undergraduate students and received funding. Shared the industrial outputs to our sponsor LeoDrive company. We would like to thank our esteemed advisor, Associate Professor Dr. Aydın Yeşildirek, for his support. Thank you for listening us.